Hello everyone, today we will solve another resultant problem. Here the problem states the resultant R equals 25 pound shown in figure 36, which is this one, is the resultant of the 20 pound and 30 pound forces and another force F. What is the force F? So we have an unknown force F and we'll have to find the magnitude and the angle of it. So let's start with the separation of each forces to the main axes. For the 30 pound we will get a horizontal portion and a vertical portion, and for the 20 pound we will get a vertical portion and also a horizontal portion. Now let's use the equilibrium system here. Summation of f of x, or the summation of all the horizontal forces, and we are taking the rightward forces as positive, equals 0. Then we will see which way all the forces indicates. For the 30 pound it's directing towards the rightward, so positive. So we can write 30, and because we don't know the angle with the horizontal force, so we will take sine 30 plus, for the 20 pound we have an angle with the horizontal force, so we will use cos 30 plus f of x1 equals 0. Then we can write f of x1 equals 30 sine 30 plus 20 cos 30. Then we will get 32.32 minus 32.32 pound, and then we will find all the vertical forces summation, and that would be summation of f of y, and we will take upward as positive, equals 0. Here for the 20 pound we don't know the angle it's making with the vertical axis, but we know the horizontal axis is at a 30-degree angle, so we can write 20 sine 30, and then we will use minus for the 30 pound because it's pulling it downward, and we know the angle is with the vertical axis, so we will write 30 cos 30 degree minus r, which is pulling it downward, so we will use the negative value, and the value of r equals 25 pound, so we will write 25 plus f of y1 equals 0. And let's calculate it. 20 sine 30 minus 30 cos 30 minus 25, we get 40.98. f of y1 equals 40.98 pound. So we can make a general determination of which way this forces indicates. Because the f of x1 is negative, it will be at the leftward direction, and for the f of y, and it's positive, so it will pull upward. So the value of the angle of f will be somewhere in this direction. So let's find the magnitude of the f and the theta. Here f equal root over f of x1 square plus f of y1 square. Then we get f of x1, which is minus 32.32 square plus 40.98 square, and if we calculate it, we get 32.32 whole square plus 40.98 square. We get 52.19 pound, and the angle would be theta equals tan inverse f of y1 by f of x1, and we will use only the value, not the negative value, because the negative indicates the direction. So we will ignore the direction and just use the magnitude. For f of y1, the value was 40.98, and for x1 the value was 32.32. So the theta would be 40.98 divided 32.32. We get 51.74. So here we have found the value or the magnitude of the force F and the angle between the horizontal axis and the force F. So that's it for this problem, and this is the answers of the problem. Thanks for watching.